Okay, so today we got this interesting problem, 1320 minimum distance to type of order using fingers. Essentially we got a word and we have two fingers and we have to calculate letter A is located at coordinate. So we have this board like a letter pad or some weird keyboard, and then we can use two fingers to type this word, and we count Manhattan distance between moving the finger and we can put initially the fingers anywhere we want. So essentially so here is my idea. The word length is 300 and it's just uppercase letters and it's not empty, or at least two. Now unless all the letters are same, we always want to use two fingers, right? And let's see, like what we need is, let's say we are at the first let's say I want to type like first I letters, right? Or I have typed first I letters ending at position J with left finger, position K with right finger, right? And now suppose, right, and we have two choices what we can do, either move left finger or right finger, right? And then we take minimum of those two recursive answers. Now one thing is that necessitates us to type already a have placed both fingers. Now this almost always happens. As I said, when we have at least two distinct letters, it's worth it. So to do it, so first what we do, so if word is equal to len word times word 0, return 0, right? Because we always press with single finger. Now in this other scenario, right, what we do, we try to type first few characters by either of the fingers, and then we pretend the next character is written, like we write first I, and I plus first is written by the other finger, and then we do recursion from there. So here is our recursion, right? Def recursion, and then we typed first, we want to type the ith character and positions are JK. Something like def decode maybe, and then x return x divided by 6 and x percentage 6, and def encode char return no, that's actually, so that's okay. So how we encode that is, so there should be char here, so x or char, right? And then how we encode a pair is, how we encode a pair, well, we got these two, and then let's ij, and then we return I times 6 plus j. Okay, let's not do this for now. Okay, so if I is n, which I probably should be fine. Okay, then we return 0 because there is we don't need to type in anything, right? And otherwise, right, we want to type that letter. such that we have fingers at JK. So we want to ordinary of I, right? So that's the position, and now so distance 1 is, so that's I1 J1, I to J2 is equal to let's see, so decode J and decode, then I guess we should pass this I1 J1 I2 J2, right? And then we want to do D1 is ups I1 minus, so I can already run, so PI PJ is decode word I PI plus ups of I J1 minus PJ I2 minus PI plus ups J2 minus PJ, right? So we got that, and now we wanna do return minimum of, great question, so minimum of recursion I plus 1, and then we move this one, so PI PJ I2 J2 plus distance 1 or recursion I plus 1 I1 J1 PI PJ plus D2. Right, okay, that should work. And then I guess I don't need this encode, maybe. Okay, and then let's see, ans could be distance and school, more I guess, 1 2 3 4 5 6 7 8 9, so 3000 can be most distance, or let's do this, why not, right? And then so we say that ans mean ans recurs and then we do this way, so then we have like position is ordinary of word I, no, so we tried, so what we need is, because we typed I plus 1 and we want to go for I plus 2, right? So n minus 1 and I plus 2, and then first position of first finger is decode of word I, decode of word I plus 1, and then this, and then n is not defined, okay, 0, interesting. I1 J1 I2 J2 res like that, so let's see. Oh, I still have to do the typing. Yeah, I forgot about that one. Okay. Okay, so let's say my position is so j1 I2 j2 is equal to decode word 0 decode word 1, right? And then we want to do this I1 j1 I2 j2, and then we want to do if I plus 2 is less than n, then I1 j1 I2 j2 yeah, word I plus, oh, no, should be like I2 j2 decode word I plus 2, like that. What? Expected 4 got 2. That's weird. Like this then. Still 0 anyways. Oh, because I'm not calculating the typed is 0, right? Then we do this. Okay, so let's pretend I'm typing 1. Typed is this, right? And then one of them stays and the other one has to move here. So new I, new j, right? And then typed ups and I minus I2 plus ups and j minus j2. And then we do typed plus this. 3 and 7. Interesting. Yeah, because I'm not changing this, so I to j2 and I and j. Okay, still wrong answer for some reason. Now I really don't know why. So if I have these two placed, right, so let's say I typed like that. So what they say is optimal here. So finger 1 on C and finger 2 on K. Finger I, finger J, right? And then we pass in finger I, finger J. So left J or left J, okay, that's better name. So left I or LJ. weird. So we have placed this finger here, and let's say the other finger will be placed RJ decode word I plus 1, right? RJ, right? And if we have that, and then new left I, new left J, is this? No, not really. RJ. Wait, so that means that what happened? So from we moved. So we typed and we move, because we now type the right, and then LI, LJ, RI, RJ, RI, RJ decode word I plus 2. Okay. Type. Let's see. So how is typed 5 after that, bro? How is that possible? Because, okay, let's say, because what is this? LI, RI, LJ, RJ. Because, how is that possible? What am I even decoding, bro? Probably something bad, of course. Like that. Okay, now it works. Okay, and this should work, I think. Yeah, okay. Interesting problem, I would say. So it's like programming O k squared times, so n times k squared let's say we typed first I letters of the word and our fingers are placed at letter char 1 and char 2. Next letter can be typed by either of the fingers and we take the minimum of distance to type next word plus rest, next letter plus rest of the word, which we find out about recursively. The problem is we first have to place both fingers. First, we can do this by trying all combinations of typing first I letters by one finger and typing I plus letter by the second finger. First letter typed by the other finger. For each such combination, of which there are n, one for all but one prefixes of word, we call the recursive function onto which we slap memoization, and voila, we have DP. And C dot K square, where length of the word and K is the size of the alphabet, since we have O states. I left finger 1 pos, finger 2 pos. And for each we do O1 work, checking, calculating, typing distance to next letter, and calling recursion. Method for rest of the word. O we also something, I don't know what. Know that we also try starting from each prefix, but that's only on. Since that is the count of states we visit. Amount of states we visit. Okay, I cannot post. Okay, goodbye.